So, welcome to video number 9 on our Most Accurate Clock on Earth series. Today we're going to look at revisit our pendulum number 3, the PLeane Pendulum number 3 that is. Now, that pendulum was this setup where we're looking at the fact that we seem to see that the bob stayed in a line with the launch angle no matter what. So it sort of stayed stationary while the I guess the suspension cable moved either clockwise or anti-clockwise. Now didn't quite understand, and perhaps Fulkoff missed this as well. To me, it makes more sense that the mass of the bob would stay in alignment during the swing. So it would actually try to keep its original trajectory from the launch, because unless another vector changing it, what's going to make it turn? Obviously, if we have vectors that will change the direction, make us go clockwise or anti-clockwise with our swing, but the pendulum bob stayed in the same line. So I noticed that quite often, but I could never quite accurately determine that, because as you remember, our bob would always turn on us or do something weird. So I think I've sort of eliminated that now and sort of got my bob more accurate and a better way of measuring this angle. Now, it's very, very hard to measure this angle, the swing of the bob, because it's just no way I can determine that. So I came up with this idea of mounting one of these little accelerometer chips, that inbuilt gyrometer and a gyro and a magnetic compass inside them. This one here is, I'm not quite 100% happy with it. The X and Y, which is the roll and the pitch angle detection, are very, very good, very responsive and outstandingly accurate. However, the magnetic compass is a little bit slow to react, and I'm not too happy with that, and it comes back with inconsistent results after it's had a bit of a jolt or something. However, that being said, for our application, because we're only hopefully looking at extremely small angle changes, that is, less than 1 degree turn with our bob, this little chip here should be adequate. So I've actually mounted one inside here now. I have 2 of these, and also you may see the screen here. If you go to that other screen, you'll see a bubble indicator there and some parameters. The X parameter is our, if you look at that angle on the X there, that's our pitch, so that's when the pendulum or the bob will swing in this direction, so you can see our X changing drastically. Our roll is the Y-axis, and you can see that changing, and of course our Z-axis is this magnetic compass showing us the angle changing rapidly there as I turn it. Now, when this bob is stationary, you can see that the bubble indicator is pretty much in the centre, and we're getting extremely small angles there, 0.03, 0.16 on our X and Y, so our bob is pretty level. Also, now this is for a little bonus for you people making your pendulums, your accurate pendulum. I know there's a few out there, you're all secret, I know you are, and you're not talking too much on the comments, but you all know that the pendulum will affect time. Now, if we got any roll in our pendulum, that is this indication here, we will get a different trajectory on our pendulum swing, and it will change the time constant. Now, I know you people out there who are actually looking at this, and you're either too frightened to speak up because this is to do with flat Earth or something, but we all know that we have not yet made an isochronous clock on Earth yet. No one has made one. All our clocks are pendulum based, from atomic to crystals to whatever. They're all pendulum based, so they oscillate between an axis with a certain length, and they oscillate back and forth. They're not, as I said, isochronous. So gravity, anything will affect them. The moment they move into a gravitational field, they slightly change into gravity. So gravity can affect them. They will change in time. So that is almost impossible to achieve on Earth. The famous clockmakers tried to do this, get around this with the tribullion, whatever it is, that tourbillon. I think it's that where the balance wheel is always in a certain position. They knew about the effects of gravity on time way before Einstein. So what we're looking at today is to investigate if the pendulum will stay in a constant plane after it's launched. And so far all my experiments are indicating that it will, so you'll obviously want to see this happen. So let's stop our clock and set up for the experiment now. And I've also got a new launch indicator and a launch mechanism to try and eliminate this swing and twist on the launch. It's much more accurate, so I'll show you that as well. So let's stop everything and we'll go now for the setup of the video launch. So here we go with our new launch. We have a extension magnet and two sacrificial ball bearings on just before they touch the bob. Now you'll see them drop as I launch the pendulum. Okay, we're all recording, right? Our pendulum has stabilised at minus 47 degrees on the z-axis. So here we go, let's launch that, and you'll see those two ball bearings drop, sacrificial. Okay. Now our angle is changing. What happened here is that magnet upsets the compass. So if you have a look at our number, our z-axis there, it's 42, minus 42 at the moment. 41, 42. It will actually stabilise, trust me. Just come across here a bit more. Might even swing around a bit more. 40 at the moment. It's just that it's been so close to that magnet. It got a bit of a shock. So far, so good with our laser line is centered on the, still on the center of the suspension cable. So at this stage we're not really worried about clockwise, anti-clockwise directions. We're interested more in our Z-axis. Seems to be stabilising now at minus 38.9, something like that. The magnet gets a shock from that. The internal compass, swinging so close to a huge magnet. But it's the only way I can launch with even the cotton. I tried the cotton, but it sort of twists the bob a bit. Stabilising now at the 38 degrees. Good to see our Z-axis, our Y-axis, which is the roll, is still very low. Of course our X-axis is that slight tilt. The fact that our bubble is still in that centre circle, which indicates to me I'm still in cosine. So our pendulum is still in cosine, which I do like. Still at minus 38. Let's have a look at our to me the laser seems to be closer to the right, coming towards us, which indicates a clockwise direction. So the bob seems to be wanting to go clockwise a bit. Very hard to say, but the good news is the bob is still on its original launch trajectory. Now, my theory is, if the Earth was to spin around, that bob should stay at 38 degrees. Still at 38. I've tried both of these chips and they both give me the results the same. This other chip here gives me these same results. So I'm inclined that it gets such a shock that the algorithm and the chip used to stabilise and get back to fine true magnetic north takes gets a bit of a shock. It has to go through a bit of reprocessing. But to me, just from eyeballing it, from lines on the bob, it still hasn't swung or changed in angle. So obviously the next thing to do is to make this thing swing for many hours and to see what happens. If the angle never changes, despite the bob going clockwise or anti-clockwise with its cable, then It's a new parameter we have to examine. Yeah, to me that bob is going maybe slightly clockwise. It's starting to lose a lot of momentum now. Probably not much point because it has lost a lot of momentum. Anyway, I might just stop the video. So this is where I'm up to at this stage, revisiting all those ambiguities that I originally started coming across, with more accurate setups and experiments to investigate them. Before I go into my next bob design, possibly an internal laser to eliminate this magnetic compass effect. It's not affected by magnets. I still need that rim around it, which is that metal ring. If you look at the previous video, for those people who want to see how the construction of this thing is made, video 8 will show you that. But I would like to eliminate that metal ring a bit lower, it's a bit smaller. Get as much metal out of this thing, much, I guess, magnetic influences. Alright, I think that's enough for this video. Thanks for watching, and stay tuned.